This tutorial demonstrates how to create a login sign-up form for your Unity app hosted by AWS Cognito that supports both username and password and social authentication. This Unity client does not use any AWS SDK drivers or extra plugins. All calls out will be made using the built-in Unity Web Request API. I'm sure there are a few other HTTP clients out there, just go with whatever you're comfortable with. Here's a list of what I'll be covering. I'll review how to create your user pool, configure the social provider, in this case Google. We're going to create a demo Lambda function, and then an API gateway with a token authorizer. I'll review the important aspects of our Unity project and how to set up a build for iOS. And then we're going to configure deep linking, or in this case universal links because it's Apple, and then we'll show you an authentication demo at the end. And here are some things you'll need before to get started: an AWS account, a Google Cloud Platform account, or whatever social provider you're using, your own domain with access to the host or server for uploading the Deeplinking config file, and a paid Apple developer program will be required to access the associated domains capability, which enables Apple's universal links or deep linking for the app. There's a lot to unpack in this tutorial, and chances are I missed something, so please take this as a starting point and be sure to do your own research to harden your app's security and authentication process. Head over to the Cognito section, select Manage User Pools, Create User Pool. Give it a name, and select Step Through Settings. I'm going to leave all the default settings here, so just go ahead and hit Next Step. For the sake of ease of this demo, I'm going to remove the extra password requirements, but I would always put these back for production. Hit Next. I'm going to leave all these to default as well. Hit Next. For the email verification, this only applies when someone signs up using the hosted UI username and password field. Those who go through the social login won't be asked to verify their email. So I like to set this to link, as it's easy to just click on a link in your email to verify the account. I would keep this on for my username and password accounts, as you probably want to cut down on fake email accounts. It is a couple extra steps for the user, but I think it's worth it. Hit Next Step, hit Next, and then hit Next again. Hit Add an App Client, name it, and I'll leave the default token settings here. Uncheck Generate Client Secret, as we don't need it for this example. And under auth flows, uncheck all of these configurations except for the refresh token one, as we don't need them for this demo. And make sure to keep the enable token revocation checked, since I'll be using the Cognito revoke endpoint later on. Hit Create App Client, hit Next Step, and then hit Next again, then hit Create Pool. Okay, so our base user pool is created, but we still have a little more setup to do. Select the domain name link under App Integration and enter any unique domain prefix here. This is required to enable the hosted UI through Cognito and will be used in our client for calling the token endpoints. And once you've confirmed it's available, hit Save Changes. We'll circle back to these settings once we get our social provider credentials. So I used the Amazon Docs as a guide for these next steps, which I'll be loosely following. So now we're going to set up a Google project for our app and generate credentials that we provide to our user pool so that we can use Google as an identity provider on behalf of Cognito to authenticate our users. We already have a user pool with a domain, and next we'll be configuring the Google identity provider. Let's scroll down to the Google section. We have to create a project, so let's head over to the Google Cloud Platform. Create a new project. Once created, from the menu on the side, select APIs and Services, and then Credentials. At the top, there's a notice to configure the OAuth consent screen, so let's do that first. Hit Configure Consent Screen. Select whether you want to use an internal or external. I selected external because I didn't want to limit it to users within my organization. Maybe you do. Hit Create, fill out the project name, support email, and website URLs. For authorized domains, you must add the domains you put for the app domain section above, and also the amazoncognito.com domain to authorize the use of their hosted UI. Finally, add your developer contact information. I just use my email. Hit Save and Continue. Next, hit Add or Remove Scopes. Let's check in with the docs, and it says we need email, profile, and OpenID for Google. So those are the first three here. select them and hit Update. Then hit Save and Continue. Hit Save and Continue again to review your settings, and then hit back to go to your dashboard. Then go to the Credentials menu, hit Create Credentials, then select OAuth Client ID. Select Web Application as the application type and name it. Grab the user pool domain we created earlier and paste it into the JavaScript origins input box. Then under Authorized Redirect URIs, enter in your user pool domain with the appended path OAuth2/IDP response. And again, we grab this from the docs. Then hit Create. Once created, you'll have access to the Google Client ID and Client Secret. Head back over to your user pool, select Identity Providers under Federation, select Google, then paste in your Client ID and Secret. Enter in the 3 scopes we set up earlier, Profile, Email, and OpenID. Hit Enable Google. Then go over to the Attribute Mapping page, select Email, then in the User Pool Attribute column, select Email again. The user pool username is set to sub, which is fine for this, but you can always change it to whatever mapping works for your project. Hit Save Changes. Go to the App Client Settings view and select all for enabled identity providers. If you don't want to use the username and password option, then keep the Cognito user pool option unchecked. The callback URLs here must match what you plan on using for your redirect URL parameter when calling to the Cognito token endpoints, as the redirect URL is what will activate your deep link back into the app. More on that later. Next, under OAuth 2, select Authorization Code Grant. This is what allows us the process of exchanging an auth code for user tokens. Then we select the 3 scopes allowed for this client again, hit Save. And then if you'd like, try out your new hosted UI by navigating to the login URL stated here in the docs. All right, well, hit pause, take a break, and go get some coffee as we've got a lot more to cover. Next, we're going to create a dummy function to put behind our API gateway that is secured by an authorizer. Go to the Lambda console and create a new function from scratch. Name it and hit Create Function. I'll just add a personal touch in the return string and then hit Deploy. Head over to the API Gateway console and create a new REST API. Name it and hit Create API. Select Authorizers, then create New Authorizer. Name it and select Type Cognito. Select your user pool we created above, then enter in authorization for the token source. When we make secured requests from the client, it will always be made with an authorization header. We'll see more on that later. Hit Create. Select Resources, Actions, Create Method, then select Get. Select the Lambda function you just created and hit Save. Select the Get Resources Method request link. Next to Authorization, select the authorizer we just created. Under the Actions menu, select Deploy API. Select New Stage, name it, hit Deploy. This will generate the API's URL. Save this off because you'll need it later in your Unity project. So at this point, our Cognito configuration, API gateway with an authorizer, and a demo Lambda function are all set. Now, in order to call this API, we must have a token that has authorization to access it. Before we get to the code, I want to start with a diagram that illustrates the high-level flow of how the authentication process will work. When a user opens the app, they are presented with the Login Signup button. Hitting that button opens the Cognito hosted UI login URL we created above and a new browser window outside of the app. Then the user will have the option to log in through the social provider, in this case Google. Otherwise, they can just sign up or log in via username and password. Once authenticated, the hosted UI will navigate them to the redirect URL we set in the user pool configs. This URL will also contain an authorization token set to the code query parameter. Since I've set up deep linking, in this case it's called universal links because of Apple, the navigation redirect will trigger the app to open, passing in the auth token generated. Our Unity app will take that token and exchange it for user pool tokens by calling the Cognito token endpoint. These user pool tokens are what we will use when making requests to our secure API gateway endpoint we created earlier. I think the code will make more sense now that you have a basic understanding of the process, so let's dive in. The login scene houses all of our interface elements for the login signup functionality. Under Canvas, the options container is where most of my scripts are attached to. The unauth interface and auth interface handles what to display when a user is logged in or not, respectively. The process deep link container is a root level object to contain the process deep link manager script. This URL with code input is just for development and testing purposes only and is actually disabled for non-editor builds. If you run this app in the editor and log in through the hosted UI that is opened, you can manually copy-paste the returned authorization token into this box to simulate the deep link token exchange process. And finally, the game scene is just a placeholder for a real game with working buttons to demonstrate API calls to our API gateway endpoint. You can see the outputs in the console logs. The UI Input Manager handles all the main screen buttons and inputs. It also handles toggling the authenticated and unauthenticated menu items. Each time the script starts, I make a call to refresh our user session token. This is a bit overkill as tokens are configured to expire after 30 days, so as long as you make this refresh call before then, it will keep the user authenticated, meaning the ID tokens returned from the request will be valid when used with requests to secured endpoints. The other thing in this class is the process deep link function. When we receive a deep link URL, this will kick off the code for token exchange process and finish authenticating our user. Let's take a quick look at the code that enables this callback. The majority of this code is taken directly from the Unity docs online. The link will be in the comments. When the awake function is hit, we register a callback function that gets called when the app receives a deep link request. Then I make a call to the UI Input Manager to kick off the code for the token exchange and handle updating the interface when the function completes. So this class's only purpose is to handle any incoming deep link requests and pass them on to the UI manager. So let's go over to the Authentication Manager and see what this exchange token stuff is all about. This exchange auth code for access token function takes in the deep link URL and pulls out the auth code from the query parameters. Then we pass it to the call code exchange endpoint function. Here we create a post request with all the required body parameters for the token endpoint. You can take a look at the docs to see where I got this from. Grant type will be set to authorization code. Your client ID is pulled from the user pool. The code parameter was part of the deep link URL that we just passed into the function, and the redirect URL must match what was configured in the user pool. The request path is built from your custom domain established in the user pool, the Cognito auth URL, and token endpoint. Then we make the request to Cognito's token endpoint to exchange the auth code for the user's tokens. There are a few tokens returned, but the one we care about for making requests through API Gateway is the ID token. And to demonstrate how we use it, let's look at the API Manager function that handles the test API call I showed you earlier in the Unity editor. Here we create a GET request with an authorization header with the ID token set to the value. If the user is authorized to use this API, it will pass through the API Gateway Authorizer and call the Lambda function behind it. And we'll see the result from the request here. I always cache the tokens locally so we don't have to re-authenticate the user each time they open up the app. You can adjust the token lifespans in the user pool if you'd like to fine-tune how long you want the tokens to last. I want to point out a couple more functions. The refresh token function will make a request to the token endpoint again, but this time uses the refresh token to generate new access and ID tokens. This was the function I was calling from the UI Input Manager's start method. It uses a grant type of refresh token, your client ID, and a valid refresh token for the body request parameters. The final thing I want to review here is the logout process. When the user clicks the logout button, we make a call to revoke refresh token. This makes a call to revoke the token in Cognito's system. You pass in your client ID along with the refresh token you wish to revoke. This action will also revoke any tokens that were generated from this refresh token. In other words, you log the user out. Then we clear out the tokens stored in the session cache. And as a side note, I must point out that there is a small gap in the Cognito's feature set. The ID token will actually remain valid and pass successfully through your API Gateway's authorizer until that token expires, which is by default in 1 hour. That means, worst case, your user grabs the ID token before you remove them and manually adds them back into the client's cache area, thus potentially allowing them to make more requests. This GitHub issue highlights a workaround which would require you to call to the STS or security token service to validate whether the token was revoked or not. Hopefully they can implement something a little more user-friendly to resolve this gap. Links in the description. So unlike my last video on authenticating a user from a Unity client, there's no actual code for handling a login. We rely on the hosted UI to perform the authentication for us. Our authentication manager just exchanges the code for a token, revokes tokens for logging out users, and calls to refresh tokens. So that's it for the code review. Next, let's look at how to configure our project to build for iOS. Set company name and product name in the player settings. This will generate a bundle identifier that's in reverse domain format. This needs to match your app's bundle ID, at least when building for iOS. I'll touch on the Apple side of this in a moment. Select the iOS tab in Settings, scroll down to Other Settings, Identification, verify your bundle identifier is what you expect. Then under API compatibility level, I selected Net Standard 2.0. I have to say that I didn't try with 4.x, so I'll leave that for you guys to experiment with. Scroll down to Configuration and make sure your target device is selected. If you plan on using a simulator for testing, select Simulator SDK. For testing on a device, select Device SDK. There's all sorts of settings you can play around with, but this is the minimum to get it to work on a device or simulator. So let's go ahead and build the app. Select File, Build Settings, and you should have the iOS platform selected. If you don't have that option, go to the Unity Hub and select Installs. Open the menu under the current build version you're using, hit Add Modules, and select iOS Build Support and go through the download and install process. Hit Build and select a folder to save it to. I always create a dist folder to save them under, just make sure to add it to your gitignore file. Let's open our iOS build that was generated by Unity in Xcode. I'm not going to go over the process of getting your project ready with Apple, but I select Automatically Manage Signing and then select my team, and that seems to work. You may run into some issues along the way, so if you do, just drop by the Discord and I'll try to help out. So what is deep linking and why are we using it? In general, a deep link is a normal hyperlink that developers can use to direct users to specific content within an app. For example, if you're browsing a clothing store's website and you click on a t-shirt, it may open that product in their app or prompt you to install it first. For our use case, we're using it in a slightly different manner. It's considered best practice to perform authorization requests from a browser outside of the app, which is what we're doing here with the Cognito hosted UI. But now we have the challenge of getting back into the app once we're done with the authorization. This is where the deep linking comes in. The authorization process requires a redirect URL, so we're leveraging it to work as a deep link, which allows the browser to seamlessly return the user back to the Unity app, thus completing the authorization process. So that's why we're using deep linking. I also want to mention that once you upload the Apple Site Association file to your website, users who visit your site on an Apple device will be shown a banner that asks them to open your app. Deep linking in general has various configuration options, and you can even limit it to work with only certain URL paths, so I would encourage you to do some more research on this topic. Let's take a look at the Apple docs and what is required to set up universal links. There are 2 steps they tell you to complete, but it's more like 4. So for the first step, you have to create an Apple App Site Association file, then add it to the root of your website. Then you have to add the associated domains entitlement to your app. This associated domains capability is why you have to have a paid developer account, otherwise you wouldn't have access to it. So let's create the Apple App Site Association file. Here's a basic template that you can use to get this to work, link in the description. Your app and bundle ID can be found under your Apple developer account, then click Certificates, Identities, and Profiles. I believe the app ID, also known as Team ID, is generated when you create your Apple account. The bundle identifier here must match the bundle identifier of the app. Remember, we set this back in the Unity player settings under company and product name. Now with that line configured, upload it to the root of your website. Then to finish step 1, let's go back into Xcode and add the associated domains entitlement. Click the plus sign at the top and add the associated domains capability. This can probably be set up through Unity, so you don't have to manually set this each time you want to build, but I'll let you guys figure that part out. Add your associated domain value, and as an important note here, this is your actual website domain. Don't include whatever subdomain you added in the reverse domain bundle identifier. I lost a couple hours on this one, so avoid my mistake. Then for step 2, we have to add the Unity code that enables our app to respond to deep link requests. Well, we've already done that, as our code in the process deep link manager responds and handles incoming deep link requests. Now your project should be ready for testing. Let's see a demo. Once our app loads, it presents the login sign up button. Hitting that will open the Cognito hosted UI in the user's default browser. Here you can sign in with any configured social provider or with username and password. For this, I'll hit continue with Google and select one of the accounts I already have an active session for. Once authorized, the redirect URL will trigger our deep link and open the app, passing in our auth code. Our app then makes the code exchange and receives the user's session tokens. And hitting this button will make calls to our dummy Lambda function through the secured API gateway. And that's it for the demo. If you have any questions or concerns, please drop by the Discord. Thanks for watching.